complete this Flex challenge, we wanted to flex our tech from our Center challenge. We knew we wanted to incorporate the tech we spent so long on, but we also wanted a new challenge. We came up with the idea to transform our time machine into a Venus flytrap. From there, we created a new story, songs, props, animation, and costumes centered around the Venus flytrap.
In order to make our story as creative as possible, we came up with the idea to create an unexpected problem. At the beginning of the story, it is expected that something goes wrong with the rocket. But, in fact, it is revealed later on that the main problem are the giant flies that live on Venus. To make the story even more interesting, we decided to create parodies of popular songs about space, which incorporated research. We used some of the skills that we learned from our central challenge. One of these was animation. Animation helps the audience in a way that cannot be told through acting.
I played the narrator, a grandma retelling the story when she was an astronaut from the first colony on Venus, in a dramatic and humorous way to her grandkid. In addition to explaining the story, she also provided witty humor and comedic relief. In every scene, we made sure that she was dramatic and memorable.
The first thing we did in our story writing process was to outline the beginning, middle, and end. We added songs not just to incorporate research, but to help develop the plot. We also added subtitles to performance to clear up any confusion.
During our point of view shot, I realized that I had to be mindful of how dizzy the shots made the audience. I could only show them in short clips, so I had to make sure that each one was as memorable as possible. During filming, I made sure to move the camera around similar to how a fly would move to make our shot as realistic as possible. Later, during the editing process, I altered a kaleidoscope filter to make the shot look like the fragmented vision of a fly. We began by designing and building an 8-sided pyramid-shaped time machine that we then transformed into a Venus flytrap. Next, we made our own pulley system with 8 pulleys attached to a central ring. We then made a crank to engage the pulleys.
Our drill-powered crank is a 2-belt double gear reduction system. The drill is attached to circle 1, which is attached to circle 2 using a belt, which is attached to circle 3. Circle 3 is attached to circle 4 using another belt, which attaches to the central rod engaging the pulley system. After much redesigning and rebuilding, we finally have a science simulator that is both reliable and innovative.
We based every part of the story around the Venus flytrap. Whenever we test if something is truly integrated, we see if our story will still work without it. Without the Venus flytrap, we would not be able to solve our problem, and there would still be flies buzzing around on Venus.
We made sure our science simulator was as dramatic and memorable as possible. Besides the fact of having a giant Venus flytrap that opens and closes on its own, we wanted to add the humorous element of donuts. Each donut was turned on the lathe by our builders, and then we had our artists add fun details like frosting and sprinkles to really make our donuts stand out.
To make our science simulator visually memorable, I painted our Venus flytrap white, and then I painted elegant vines on the outside. I painted the vines brown and silver to camouflage with the harsh terrain on Venus.